All right, your test is going to cover 4-1 and 4-2. Just our basic stuff from your quiz, which I'll get back to you guys in a minute. And then the rest of it is right triangle stuff. It's going to be heavier on the right triangle stuff. I gave you a review. It's posted. You guys are welcome to start it. Tomorrow, any questions you have, I'll go over with you. I will make sure everything is worked out and posted so you guys can ask questions and that sort of thing. But remember the difference between round your answer to the nearest, that means the decimals, okay? And God bless you. And give me an exact answer. All right, so exact means you should have a square root in your answer, no decimals. And we'll talk about the special right triangles, the 30, 60, 90s, and the 45, 45s, 90s in a minute. But right now I want to focus on word problems. All right, you guys, once we set the word problem up, y'all are fine with finding the height. You're fine with the mechanics behind how to solve a trig equation. It's getting everything set up that can be tricky. So the difference of the wording would be angle of elevation versus depression. We talked yesterday that the angle of elevation, this is a really good description of it, is always measured from the ground up. It says to think of it like an elevator that only goes up. It's always inside the triangle. When you draw your triangle, it's always that bottom corner angle that's formed with the ground when they say the angle of elevation. All right, when they say the angle of depression, I drew this for you yesterday, the angle of depression is on the outside of the triangle. Your angle of depression is here. So it's not inside your triangle. You can't use that angle down here in the corner, or down, you can't use that angle as your theta up in the corner and just say, oh, this is what it is. There's two ways you can find angles inside the triangle. If you want to use this corner angle up here, this forms a right triangle. So to get this angle inside here, you would say 90 minus whatever they give you for the angle of depression. Or, which I think is easier, is if they give you the angle of depression from the top, that's the same would be the angle of elevation on the bottom on the inside of the triangle. I would always go with that method. It's just easier to see. It's easier to figure out. It's easier to look at. Look at this diagram here. It's exactly what I just explained. If they tell you the angle of depression from the top of the lighthouse is 35 degrees, this is what they're telling you. So if you want to use this as your theta, as your reference, you had to do the 90 minus 35. That's where they got the 55 degrees from. But if you want to use 35 degrees, you just have to put it in the right spot. If they tell you that the angle of depression is here, they're telling you that the angle of elevation is the same thing down here. Utilize the fact that the angle of depression equals the angle of elevation. You just have to put it in angle A, the one that's formed with the ground. That is the easiest way to do it. I'm going to go through these problems and work them through and set them up, and you guys are going to see, oh, okay, there's two different ways I could do it. We'll do it that way. All right, so we're going to go through problems. I'm not working all of them out. I already have, but right now that's going to be your job. We're going to work on setting them up. This first page is pretty basic, and then the next two are a little more challenging, so I want to make sure we get to those together. But if you look at a question like this, first of all, I told you guys yesterday, we're talking about right triangle trig, yes? So what should you draw for all of your pictures? A right triangle. Again, you could draw it however you want. I always draw mine the exact same way every time. Now here it says round to the nearest hundredth. I think on my answer key I rounded everything to the nearest foot just because it was easier. Just read your directions on your test. But it says a tower casts a shadow that's 60 feet long and the angle of elevation of the sun is 65. How tall is the tower? So let's think about what they're asking. Would you guys agree with me that the tower is right here? Yeah? If I want to know how tall it is, what am I looking for? The height. That's what I'm looking for. They told me that the angle of what? So where are they telling me? Bottom right or top left? Bottom right. So 65 is here. So I have two pieces of information. I have another piece. This is where the tricky part is. The tower casts a shadow. Guys, if you're standing in the parking lot, where is the shadow? It's on the ground. So where does the 60 go? On the bottom, right here. Now everybody in here can solve this. What trig function uses, if this is my theta, 65 degrees is my theta, what is x? The opposite, right? And what is 60? My adjacent. So what trig function am I going to use? Tangent. You're going to say tangent of 65 equals opposite over adjacent. Remember, you're setting yourself up here, it's a fraction equal to a fraction. How do we solve this? You cross multiply. So 1 times x is x. 60 times the tangent of 65. You can round to the nearest foot. That's fine. What do you guys get? 129? So it's about 129 feet tall. Now, if you got a negative or something like that, check your calculator that you're in the degree mode. You don't want to be in radians. If you didn't get that answer, talk to me in a second. Come see me after class. Come see me after school so we know how to work our calculator. That's important. But it's the setting up that is the hardest part. So I'm going to go through and set a couple of these up. I'll let you guys finish them. I just want to make sure we get to the challenging ones first. Or we get to the challenging ones. And I want to answer some 30, 60, 90 questions. So now we have our friend Matt. Okay, here's Matt. Hold on, let's draw a right triangle. It says Matt is standing on top of a cliff 305 feet above a lake. The measurement of the angle of depression to a boat on the cliff of the lake is 42 degrees. How far is the boat from the base of the cliff? Okay, so you guys agree with me that my boat's here, right? Where is Matt standing? At the top. Matt's up here at the top of the cliff, right? You guys agree? Okay, so it says Matt is standing on top of a cliff 305 feet above the lake. What are they telling me? What is 305? The height. Okay, this is 305. It says the angle of depression. So they're telling me that this is 42 degrees. Now here I have two options. I can either say 90 minus 42, which is what? 48. I can say this angle on the inside here is 48, and I can use that as my reference. Or I can say this angle here is 42, and I can use that as my reference. On my answer key that I did, I worked them both out using both different angle measurements. You use a different trig function, you get the same answer. But the question is, how far is the boat from the base of the cliff? Guys, where is the base of a cliff? Is it at the top of the cliff or is it at the bottom? So they want to know how far the boat is from here to here. You guys see that? So this is the value that I'm looking for. So if I use 42 as my theta, what trig function am I going to use? Tangent. Okay, so it'd be tangent 42 equals what? 305 over x. Okay, hold on one sec, Cassie. Say I wanted to use 48. Somebody else used 48. What would you say? Still tangent? Okay, so tangent of 48 equals what? X over 305. Cassie, question.
So we can't use like the theta that's on the top that says 42?
No, if you use that, it has to be in the angle of elevation spot. Because that angle of depression is on the outside of the triangle, it's not on the inside. Now, guys, if you work this out, somebody work out red, somebody work out blue. Do it real quick. I'm not going to work every single one out, but somebody work out red, somebody work out blue. Who's working out red? Okay, Paulina, what'd you get?
339.
339. Okay, who's working out blue? Allie, what'd you get? 339. Whichever you choose, as long as you mathematically do it correctly, you get the same answer. But Cassie just asked a great question. Can I use this 42 here? You can't use it as the angle of depression because it's outside the triangle. You have to find the angle inside. So either way you guys want to do that is perfectly fine. All right, let's go through and set some of these up. I'm not going to finish them all. We'll just set some up, and then we'll go to the harder ones. Oh, look, it's our friend Matt again. What's Matt doing? He's standing on top of the same cliff. So here's Matt again. He's standing up here. The cliff is still 305 feet, right? The measurement of the angle depression, oh, it's the same. So this is 42 here. So I know that I can use 42 here, or I can use 48 here, right? 90 minus. God bless. My boat is still here in the water. But it says, how far is the boat from Matt? What are we looking for in this case? The hypotenuse. We're looking for this measurement. How far is Matt from the boat is the hypotenuse. How far is the boat from the base of the cliff? That's the horizontal. Do you guys see the difference? So in this case, you would set up, if I use 42 as my theta, what trig function would I use? I would say sine of 42 equals 305 over x, right? Well, what if I use 48? Cosine of 48 equals 305 over x. Yeah? You guys agree? Now, either or, it doesn't matter. You can do either one, but you get the same answer. So it's like a choose your own adventure. You can do whatever you want. But if they give you the angle of depression, your two options are, say, 90 minus to find the angle at the top on the inside, or you can just say the angle of depression on the outside is the same as the angle of elevation on the inside. All right, let's move along. You guys can finish those later. Stay with me. All right, draw another right triangle. A ladder that's 20 feet long is leaning against the side of a building. What did I tell you yesterday about ladders that lean? What is that telling me? The hypotenuse. Good. Very good. If the angle formed between the ladder and the ground is 75, where does that go? Where does that go? Bottom right. Good. How far is the bottom of the ladder from the base of the building? Think about it. Here's the bottom of the ladder. Here's the base of the building. What am I looking for? The vertical or the horizontal? The horizontal. What trig function would you use? Cosine. Good. If I just gave you that triangle, you guys would all do it in 2 seconds. It's a matter of figuring out what goes where. Again, don't solve all these. Just go ahead, set it up. You guys can come back to it. I want to make sure we understand how to set these up. Right triangle. Now we have my friend John. John wants to measure the height of a tree. As soon as I see height of a tree, I go like this and I draw a little tree. He walks exactly 100 feet from the base of the tree and looks up. So here was John. He walked. Now he's standing here and he's looking where? He's looking up. What does that 100 tell me? The horizontal. That's how far he walked. They told you he walked 100 feet. And he's looking up. It says the angle from the ground to the top of the tree is 33. Where does that go? Right here in the corner. And then the age-old question, how tall is the tree? What are we looking for? We're looking for the what? The height, the tangent. If I was looking for how long a ladder would have to be to reach the top of the tree, we'd be looking for what? Hypotenuse. Good. All right. All right, a flagpole in front of C.B. Smith. We're all familiar with C.B. Smith. We all know what a flagpole looks like, right? Everybody familiar with the flagpole? It casts a shadow 40 feet long. Where are shadows, guys? On the ground. So here's my 40. The angle of elevation to the sun is? Where does that go? Bottom right. And I want to know how tall the flagpole is. What am I looking for? X. I would use tangent again. Again, it's not always tangent. As I go through, guys, if you're having questions, stop me. Say, hey, how did you get that? Yeah. Yeah. For any word problems, that's a good question. If it's feet, inches, meters, you want to have the unit for the word problems. Yes, ma'am. Because it says the angle of elevation. As soon as they tell you it's the angle of elevation, you know it's the angle that's formed with the ground. All right, I told you guys yesterday about a kite. Think about a little kid at the beach flying a kite. When he stands there with a kite string, it doesn't go straight vertically up in the air, right? His arm is slanted, the kite is kind of like at a slant from his arm. So think about that. Kelly is flying a kite to which the angle, God bless you. The angle of elevation is 70 degrees. The angle of elevation. Where is the angle of elevation? Where? Angle of elevation. Bottom right. It's always formed with the ground here. Why did I put 65? Sorry. 70, that's what I meant. The string on the kite is 65 meters long. What is that telling you? The hypotenuse. You have a kite. It does not just go from your hand straight vertically in the air. That doesn't even make sense, guys. Think about holding a kite. Think about that. So they want to know how far above the ground is the kite. What are we looking for? The vertical or the horizontal? The vertical. I use X every time. You guys do not have to. You can use Y. You can use whatever letter you want. But in this case, what trig function are we using? What are we doing? Sine. Good. Because it says, how far is the kite above the ground? So remember, a kite's going to be flying, right? And here's the ground. So it wants to know how high the kite is.
So what would it have to say to be on the horizontal?
How far is Kelly standing from the base of the pier? Something like that. All right. Right triangle. We're getting a little wordier. From a 200-foot observation tower on a beach. You guys ever been to treetops? So they have that observation tower you can walk up? Okay, think about that. But a 200-foot observation tower. What is that telling me? The height. There's a tower that this man is standing on that's 200 feet tall. The angle of depression to where he sees a poor whale in difficulty. It's a whale in distress, guys. The angle of depression from where this man is standing in his observation tower down to the whale is 7 degrees. Okay, now I have some choices here. I can use 2 different measurements to solve this equation. What's one measurement I could use? 7 degrees. Where? I could put 7 degrees down here. That's perfectly fine. What's another measurement I could use? Where would I put 83? Up here. If you want to use that top angle, that's fine. You have to do the 90 minus. But the question says, how far is the whale, Mikey, from the shoreline? Here's the whale, and here's the shoreline. See what we're looking for? Yeah. If it was how far is the whale from the man on the observation tower, what would we be looking for? The hypotenuse. Good. Good. It's all about semantics. It's all about looking at this. All right. Now let's go to the next page. If you notice, we have working on those. You guys will have time. I want to get to these ones. They're a little trickier. I didn't have time to retype them all, so, fancy. Again, we're talking about a what? A right triangle. I don't care how many words are in this. It could be 2 paragraphs. It's a right triangle. A damsel in distress is being held captive in a tower. What's the really only piece of information you need there? The lady's in a tower. She's a damsel in distress. It's like a Disney movie, guys. Her knight in shining armor is on the ground below with a what? With a ladder. When I think about a knight down here with a ladder, what part of my triangle is the ladder? The hypotenuse, okay? Not saying we're looking for it, but good. That's good thinking. When the knight stands 15 feet from the base of the tower, Mikey, what is that? If he's 15 feet from the base of the tower. Perfect, good. Do you see what? I'm not picking on you. I'm just trying to. He looks up at his precious damsel. The elevation is what? 60. Where does that go? Bottom right, good. Now here's the biggest question of them all. How long does the ladder have to be? What are we looking for? The hypotenuse. If I said, how tall is the tower? What are you looking for? The height. Good. Very good. You guys have got to make that distinction. And then you figure out what trig function you're going to use. All right. Here we go. We're going to think a little bit here. Suppose you're flying a kite and it gets caught in the top of a tree. That's true. That could happen very easily. So here's my tree. Right? The kite is stuck in it. Right? You let out all the 100 feet of string that you had in the kite. What is that telling you? The hypotenuse. Remember, string of a kite doesn't ever go straight vertically up and down. It's always going to go at an angle. So that's telling me the hypotenuse. It says the angle that the string makes with the ground is 75 degrees. That's going to go bottom right, correct? Now, there's two questions that could be asked here. How far are you from the bottom of the tree, or how tall is the tree? So let's keep reading. It says, instead of worrying about how to get your kite back, you wonder, how tall is that tree? What are you looking for? The height. You're looking for the height of the tree. If you were wondering how far you were from the bottom of the tree, you'd be looking for the horizontal. All about semantics. Yes, ma'am.
This is angle elevation because it says the string that makes with the ground.
Anything with the ground. Good question. Anything, the angle made with the ground is always going to be the angle of elevation. The way that I draw my triangle, bottom right corner. If you draw it the other way, it'd be the bottom left corner. Yes, ma'am.
So how would you know if it's the angle of depression?
It'll say it. Or it'll say like, Ashma's standing at the top of a cliff looking down at an angle of. So it may not say the angle of depression is, but if someone's standing looking down, that would be your angle of depression. Good. All right, this one's tricky. So don't get frustrated and don't ask me, are we going to have one like this on the test? If I'm going over it, it's a possibility. So let's just talk about it for a second. A submersible traveling at a depth of 250 feet. Guys, do you know what a submersible is? It's a submarine, okay? So look, I'm going to draw. This is amazing. Watch out. Oh, I should have drawn it yellow. Do you guys know that song? Okay, there's my submarine. That's not bad. That is not bad. I've seen worse. But it says my submersible is traveling at a depth of 250 feet. Do you think that that's an important piece of information? Okay, let's just think about it for a second. Do you see my water line that I drew? Okay, so how far is the submarine from the top of the water before it even starts? 250. Okay. We might need it, we might not. Let's just make sure we visualize it. It says the submersible dives at an angle of 15 degrees with respect to a line parallel to the water surface. If something is diving, which way is it going? It's going down. Okay, does that make sense? So they just gave me, Ashma, on that one, the angle of depression. So guys, here's make a choice. Do you want to use 15 in your calculations, or do you want to use a different number? We can use 15 or what? I can use 15 down here or 75 up here, whichever you want.
It doesn't really matter what number I'm using the calculator anyways.
Well, if you let me set it up for you. Hold on. That's a good question. It says it travels a horizontal distance. That's a major piece of information. What is that telling me? 1,500, right? What is the depth of the submersible after the dive? So given your triangle, they're asking for the depth, which is what? The height, right? You guys agree with me? So, Mikey, here's your question. If I use 15, right? If I use 15, I'm going to say tangent of 15 equals x over 1,500, right? You agree with me? If I use 75, I'm going to say tangent of 75 equals what? 1,500 over x. Do you see how it's not going to be the exact, like, your ratio wouldn't be the same, or sometimes the trig function is different. But guys, once I find this value here, this is where we need to think a little bit. I'm finding this value right here. The question asks, what is the depth of the submarine after the dive? The submarine started off already how much? 250 below the water surface, right? So once you find your x value, what do you have to do? You have to add the 250 feet. Because they want to know how far total it is. Does that make sense? God bless. Uh-huh.
How did you know that the 15th was an angle?
Because it says that it was traveling at a depth of 250 and it dives at an angle of 15. If something is diving, it's going down, right? You guys are going to be okay with this, I promise. All right, here we go. This is Mikey's family. Bob and Tom cats. There's more cats in the world. They buy a tent that has a center pole that's 6.25 feet in height. If the sides of the tent are supposed to make a 50-degree angle with the ground, how wide is the tent? All right, let's think about the triangle that we're going to draw here. I'm going to draw it like this because what did they tell me right here? What did they tell me? There's a what? A center pole. Do you guys agree that that is the center of a triangle, like of your tent? How tall is this tent pole? 6.25 feet. All right, if the sides of the tent make a 50-degree angle, so this is 50 here, this is 50 here. Do you guys see that you just have two triangles? Actually three, but two little ones. Right? It says, how wide is the tent? Where would the width be? At the bottom, okay. So when I find x, am I finding the whole width? No, I'm only finding what? Half of it, right? So what do I have to do once I find x? You have to multiply it by 2 because you're looking for the width of the whole tent. So this would be 2 times x. They tell you the center pole, that means it's in the middle. And then from that center, the two sides make 50-degree angles on both sides. They're telling you that it made two congruent triangles. Yes, ma'am?
Would you be able to solve it if you didn't see the draw a triangle that way?
What did you do?
Start off with the regular,
Say it again. I'm sorry.
start off with the regular triangle that we use.
Okay, so you went like this, yeah? Okay, so you said this was 6.25. Okay, and then you said this was 50. And you want to find the width? Okay, that's perfect. The only thing is your tent, the center pole, this is in the middle. So it's splitting it in half. You have another triangle over here. But yeah, you could have definitely drawn that. Yep.
So once you find the x, you multiply
By 2. Yep. All right, let's think about Ophelia, pain. Get it? Like, I feel your pain. Uh-huh.
Well, I thought that you would divide the two because the x would be like the full width.
The x is only that half because you're using the center pole as the height. So you're only finding half of it.
But isn't the center pole part of like both triangles?
The center pole cuts the triangle in half. So you're finding the height of that, and then it forms the right angle here, so you're only finding half of the width. You got to find the other side too. Ophelia Payne is walking to her office building. She knows is 150 feet tall. What is that telling you? The height. She knows that it's 150 feet tall. She's walking to her office building. She knows the angle to the top of the building from her current location is 6 degrees. Okay, so think about it. Here's Ophelia, right? She's walking to her office building, right? Agreed? Her current, from where she is right now, she's walked this far. When she looks up to the top, she has the angle of elevation of 6 degrees. What is that telling me? Where? Where does that go? Okay, bottom right. The question is asking from here, where she's currently standing, how much further does she need to walk? What are they asking for? The horizontal, the bottom here. How much further? Think about it. If you're walking to the front door or something like that, you're not walking up to the top of the building. You're walking from where you are to the front door. All right, let's talk about 10. Bits of information that means something in these questions. A 5-foot tall bird watcher is standing 50 feet from the base of a large tree. All right, let me draw my picture. Here's my tree, right? A bird watcher. How tall is this person? How tall is this person? 5 feet. Do you think that's important? That they told you that this person is 5 feet? Because think about, we've talked about angles of elevation and depression. It's always from your line of sight, from where you're standing. So it says they're 50 feet from the base of the tree. How far is the bird watcher that I just drew from the bottom of the tree over here? 50 feet. So do you guys agree with me that's 50, yeah? Okay. The angle of elevation to the top is 71.5. You guys agree that goes there? Yeah? How tall is the tree? What are we looking for? The vertical, the X. What is important about that 5 foot? Why do you have to add it on? You're right. It's not included. Like, think about it, guys. I'm 5'7"-ish. So if I'm standing here, here's my line of sight, here's my eyes, right? And I'm looking to the top, I want to see how tall that tree is. From my line of sight, is there a gap from my eyes to the ground of how tall that tree is? So once you find your X value, you have to add the 5 feet, however tall the person is. Very similar to when we had our submarine that was already 250 feet down. To find the total height, you have to take into account if someone's standing, looking. If they say someone's laying level on the ground, they mean it's level on the ground, that sort of a thing. Just read the words, practice this, keep reading, try to find little clues. All right, this last one is not that much of a doozy. It appears to be, but it's not. Okay, there's 2 ways you can draw these triangles. And then we'll go over some stuff. Will give your quizzes back. It says, at a point 200 feet from the base of a building. Okay. So here's my building. At a point 200 feet from the base of a building, so that would be here. This is 200. You guys agree? The angle of elevation to the top is 53 degrees. Do you agree with me that this is 53 degrees like that? Yeah? Oh, wait, did I skip something? Oh, I did. I'm sorry. Hold on. Angle of elevation. Oh, there's a smokestack on top. Okay, there's a smokestack. It says the angle of elevation to the bottom of the smokestack is what? 35 degrees. And then it says the angle of elevation to the top of the smokestack is how much? 53 degrees. Now, you can look at this problem and be like, what? It says how tall, or find the height of just this smokestack. This is all I want to know, is just this piece here. How in the world would we do this? Say it one more time, Ellie.
We find that the height using the 53 degrees.
Uh-huh.
And then subtract it using the height.
Absolutely. How many triangles do we have here, guys? There's 2. Break it up into 2. You have a triangle that goes to the bottom of the smokestack. So that would be 35 here. This is 200. And you're looking for that. Then you have another triangle that goes to the top of the smokestack. Still 200. Now I'm going to use 53. And you're finding this. Well, I'll use a different letter. So how would you figure out how tall just the smokestack is if you know the height to the bottom of it and then the height to the top of it? How would you figure it out? You subtract. That's it. So you find your x and your y, and then at the end you say y minus x, and that gives you the height of the smokestack. Now what I want you guys to do is I want you to try and solve these. I set them up already for you. It'll take you 10 minutes to probably do this in your calculator. But I'm going to post everything worked out by the end of the day. I already did it. I'll just do it at the end of the day. So you guys can kind of look back and reference and see, okay, what words gave me this? What words gave me that? That sort of a thing. All right. As far as the 30, 60, 90s, 45, 45, 90s go, I'll go over them a little more tomorrow. But you guys should know these. You guys learned this in geometry. You should have talked about this in Algebra 2. You'll have your calculator on your on your test. You'll have a unit circle to try and use that to figure out. But does anybody know the pattern for a 45, 45, 90 and a 30, 60, 90? It's 1, 1, square root of 2 for a 45, 45, 90. Meaning, if I have a triangle and they tell me this is 45 degrees, and they tell me this side is 4. You can tell me the other two sides. What is this leg here? 4. What is this leg here? 4 square root of 2. This is 4. It's just a pattern, guys. So if I have a 45, 45, 90, and they tell me that this is 6, find the other ones. Well, I know that that side is root 2, x root 2. So you just say 6 equals x square root of 2. Whoops. Divide both sides by the square root of 2. So x equals, can you have that? Can you leave 6 radical 2? No, so you're going to, so you have 6 square root of 2 over 2, which would become what? 3 square root of 2. So you just found your two sides. Right there is 3 square root of 2, and that's 3 square root of 2. Same thing goes when you have a 30, 60, 90. The side across from 30 is 1. The hypotenuse is always 2. And side across from 60 is a square root of 3. So if you have a 30, 60, 90, right, there's my 60, and I said this side was 14. Well, what's the side across from 30? 7. And then what's this side down here? 7 root 3. There you go. You're going to have questions like that where you have to use exact answers, no decimals. So it's important that you guys look at those patterns. Google that tonight. Look over some YouTube kind of stuff. We'll go over some more tomorrow. But